Number 10. For each of the following problems, first decide if the equation is linear, separable, or both, and then try to find the general solution. So in this problem, notice that because we have this exponential function with the y as part of the exponent, this e to the 2y is not linear in form. So this is not a linear differential equation. It's separable if it's possible to write this right side as a product. And it is, if you remember the rule for exponents. I'll write it up here. Remember that if you have some number raised to a power times that same number raised to another power, you can multiply these two numbers together, and because the bases are the same, you can add the exponents. A to the m power times a to the n power is equal to a to the m plus n. So what we have over here is we've got something raised to the sum of two powers. You can use the same product rule for exponents to rewrite the equation. So I have my derivative is equal to e to the x times e to the 2y. So notice I have my derivative equal to a function of x times a function of y. This one is separable. Now, because the equation is separable, we want to rewrite this so that we have all the x terms on one side and all the y terms on the other side. I'm going to write this derivative as dy dx. And then rewrite this by, I'm going to have to bring my x terms over to the right side to get the dx out of the denominator. So I'm going to multiply each side of the equation by dx. And because I'm getting my x terms on the right side of the equation, I'm going to want my y terms on the left side. So to get rid of this e to the 2y from the right side, I could divide by e to the 2y, or I could multiply by e to the negative 2y. Okay, so multiplying through by dx e to the negative 2y will give me e to the negative 2y dy equals e to the x dx. Now that we've separated the x and the y terms, we can go ahead and integrate both sides of the equation. On the left side of the equation, we're integrating this exponential e to the negative 2y with respect to y. When you integrate an exponential with a linear exponent, you get back that same exponential divided by the coefficient of that linear term. So here on the left side, I'm going to get e to the negative 2y over negative 2. On the right side, integrating e to the x with respect to x gives me e to the x. And on this side, I'm going to put my constant of integration, plus c. Now, here we have our solution, but if at all possible, you want to try and solve for y. So I'm going to start solving for y by first multiplying by negative 2 to get this negative 2 out of the denominator. When I multiply by negative 2, that's going to leave me with this exponential on the left side, e to the negative 2y. And on the right side of the equation, I get negative 2 e to the x minus 2c. Then, to get rid of this exponential, we can apply its inverse. The inverse of an exponential is a natural log. And so if I apply the natural log to both sides, that natural log gets applied to both terms together on the right side. You can't distribute through by the natural log. But on the left side, natural log and e will cancel out. I'm going to bring this up. And on the left side of the equation, it leaves you with negative 2y. On the right side of the equation, we have natural log of negative 2 e to the x minus 2c. And there's really not a way to break up these two terms. So I'll have to leave it that way. But to solve for y now, all we have to do is divide both sides by negative 2. I guess it would be nice if you could cancel those negative 2's out, but you can't. And probably the best way to write this is as negative 1/2, bringing that negative 2 in the denominator out, times the natural log of negative 2 e to the x minus 2c. And there's our answer. On number 11, here decide whether it's linear, separable, or